Welcome to the California and Nevada Drought and Climate Outlook Webinar. Thank you for joining us this morning, sorry about that. Before we get started and talking a little bit more about NIDIS and digging into the webinar, I just have some logistical items to discuss. So throughout the webinar, if you have questions, please put them into the question box on the GoToWebinar panel, and I will monitor those, and depending on timing, we can ask them all at the end or after each speaker. And so for our lineup today, we have Dan McAvoy, who's going to be doing the Drought and Climate Update and Outlook, and then Nate Patrick from the California and Nevada River Forecast Center. We'll be talking about the forecast products and tools that they have on their website, and then we'll wrap up with me, Julie Klansky, from Scripps Institution of Oceanography, talking a little bit about some of the forecast products we have on the Center for Western Weather and Water Extremes website, and also the CMAP website. So before we jump into the webinar, I just wanted to give a little bit of background on NIDIS. So the NIDIS mission is to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and better prepare for and mitigate and respond to the effects of drought. NIDIS works to improve the understanding of how and why droughts affect society, the economy, the environment, and to improve accessibility and dissemination of early warning information for drought risk management. And do this through 5 different pillars, which are, oops, there we go. Observation and monitoring, interdisciplinary research and applications, communication and outreach, prediction and forecasting, and planning and preparedness. And then also, before I turn it over to Dan for the update, I want to talk about just briefly some new features on drought.gov. So one of the new features is there's a new ability to display the full map description within an image. This also helps provide necessary context for the new drought maps and more explanation. And then you also have the ability to overlay any map on drought.gov with tribal nation boundaries. And so these are just some of the new features on drought.gov. I will also, each month we do a drought status update, which you can see on the California and Nevada DEWS page. So that's just a little bit about NIDIS, and now I will turn it over to Dan McAvoy for the update and outlook.
All right, let's see here. We looking good, Julie?
Yes, looks great, thank you.
Okay. All right, well, thanks, Julie, for the introduction, and I'm happy to be here today, and I want to give a brief update on our current drought conditions, where we stand, and what we could maybe expect in the coming days to the next season in terms of the outlook. I'm a climatologist at the Desert Research Institute in Reno, Nevada, and also the Western Regional Climate Center. And I took this picture here, this cover slide from Mount Rose ski area, and they opened fairly early this year on the weekend of November 13th, due to some early season snowfall. So I want to talk about what that might mean for the current drought and what that could possibly mean, if anything, moving forward into the season. So let's just start out with the current drought conditions, a snapshot of the current drought conditions based on the latest U.S. Drought Monitor map, which this map was released last Wednesday, the 23rd, and this is the latest map. The colors, these maps are released weekly with updated drought conditions, and the colors indicate the drought severity, with the darker reds indicating more extreme or exceptional drought. And so we see the entire region, both states are colored in one of the colors there. And so the entire area, with the very exception of a small corner, I'm sorry, trying to get my cursor to work, but it's not working. with a small corner of northwest California there, which is in yellow. That is abnormally dry, not a drought category. The entire rest of the region is still in drought. This has been an ongoing drought. And with the Central Valley, parts of the Central Valley, southern Central Valley, and foothills of the Sierra in California in that D4 exceptional drought category. So we're still currently in a widespread drought across the region. But we really need to look back in time and put this into context and understand that this has been an ongoing long-term drought. And so this is showing the same type of drought snapshot, but now for the past 4 years, going all the way back to 2019, around this same time. And we have to go all the way back to 2019, was the last time the region was really mostly not in drought, although there was still quite a bit of area in that abnormally dry. And so we had 3 water years in a row with drought conditions. And so now we're entering the 4th water year. That could either be another drought year, or we can perhaps improve or get out of the drought. But the fact that we've been in this for 3 years now, we've dug ourselves a deep hole. So it's going to take above average rain and snow, well above average, not just a ho-hum normal year, or multiple years in a row to really get out of this drought in terms of a water supplies perspective. So how have things started so far this season? I did show there was some snow in early November, so that was a good thing. And so this map is showing the percent of average precipitation for the water year to date so far, so starting on October 1st. And this was updated through November 24th, and it's the percent of average precipitation. The browns are drier than average, and the greens are wetter than average. And so we see across the northwest part of the region that there's more browns, and then as you go into Southern California and parts of Northeast Nevada, there are some greens. So it's a bit of a mixed bag in terms of anomalies, relative anomalies. So most of the precip that did fall was in about 1 week in mid-November. And I'll show more about the timing of that. But we do have the wettest months ahead of us still, at least climatologically speaking. That's December through February, when the biggest storms tend to occur during those months and bring the most water to the region. So we really need those months to deliver, which didn't necessarily happen all of last year except for December. And again, the timing of when these storms come is also very important. And if we now look at the timing of what's happened so far this year, we'll start off with the Northern Sierra Nevada region. So this is from the 8-station index, which is 8 different weather stations throughout the Northern Sierra Nevada that represent the region. This is showing the cumulative water year precipitation starting from October 1st. And then as you go over to the right, it goes through the end of the water year. That shaded blue coloring is the climatological average. And then the dark blue line with the arrow pointing at is what we've seen this year. The lighter blue trace above is what we saw last year in the 2022 water year. And then the red line is the record wettest year, which was water year 2017. And so if we look at this year, we see we really had almost nothing in October. It was very dry and quite warm in October. But then we did have a series of storms in early November, which did bring some soaking rains, several inches of rain, and plenty of good mountain snow pack to start the season. But then it has dried out again over the past few weeks. And based on this index, this region is about 56% of average for the date. But we can just look at those other 2 years I have up there and see how quickly things can either turn on and produce heavy precipitation really quickly, or dry out for months at a time and turn a good year into a drought year like we saw last year, where you can see that things started off really good. Last year was actually on pace with 2017 up until about January 1st. And then things just shut off and we ended up having another drought year, which was really hard to believe after how wet it was last December. So the point being that with a few more good storms, we can make up the deficit we're in right now and get back to an average or an above average water year. If we move further south, so this is a similar type of graphic, but now it's showing precipitation for San Diego County. And so this is as a percentage of the normal for the whole water year. And so that 21.9% is the percent of the total water year total so far this year. And so you see that there were some small storms in October that brought the region slightly above average. And then the November storms were really good for the region, brought the region well above average, well ahead of the curve. But again, there's been a long dry spell, and so things are turning back closer to normal. But the rain, and plus, as I'll show, the cooler temperatures have really helped to reduce the drying and also the fire danger, which is still a big deal this time of year in Southern California. So as I mentioned, those storms did bring some early season snowfall. This map is showing the SNOWTEL network and the California Cooperative Sensor Snow Pillow network. Snow water equivalent percent of median for the date. This was as of the 26th of November. And the blues indicate the dark blues indicate over 150% of median snow water equivalent for the date. So most of the Sierra is above average for the date. Northwest California is below average, but we're really early in the snow season, and a couple good storms could change things for Northwest California. But if we do dry out, things can also fall below average very quickly. So the snow numbers this time of year, it's good to have the snowpack there, but the actual percent of medians this early in the season aren't necessarily all that meaningful. So I mentioned the cooler temperatures. I want to talk about the cold temperatures in November so far, and it's been an exceptionally cold November for our region and really the entire Western US, and not just relative to the past few years, but really relative to the past several decades. And so the map on the left is showing the November 1st through the 24th, the mean temperature anomaly, the difference from average. And the blues are colder than average and the reds are warmer than average. And for a change, we don't see any red on this map. It's all blue, and there's actually a really big area in that darkest shade of blue, which is 6 to 8 degrees Fahrenheit below normal for that period in November. So a very cold start. And then on the right, those squares are showing long-term weather stations, and the colors indicate the ranking of the November 1st to the 26th mean temperature rankings. And anyone that shows a number 1 is the coldest November on record so far. And anyone in that magenta pinkish color is the 2nd to 5th lowest temperature for November. So it's been widespread cold with some record cold so far for the region. And some of these stations have long-term climatologies. And so this might not seem all that important, but it really has helped reduce drying of the soils, even some melting of the mountain snow. And it's also, again, reduced that fire danger in places like Southern California. And I just wanted to show some perspective. This is one of the locations in Northeast Nevada, Elko, that has temperature records back to 1891. And so far through the 26th of November, this has been the coldest November on record. And you can see how cold it's been relative to the past few years. Last year was about 15 degrees warmer than this year. And so a big change from last year and the past few years, and really much colder than any November we've seen in the past 20 years in the region. And so again, with those cooler temps plus the good precipitation in November has reduced the drying of the soils and actually wet up the soils in some spots. And so these two graphics are showing soil moisture conditions. The one on the left is showing the column soil moisture, the top meter of soil, and the percentile ranking. So the oranges and the reds are drier than average, and then the greens and the blues are wetter. And so we do see a mixed bag, but we don't see the entire map covered in those two darkest colors of red, which we have seen in recent years. And so it's good to see that these cooler temperatures and rainfall has helped the soil situation a bit. And then on the right is a time series showing the observed soil moisture from SNOWTEL stations in the eastern Sierra Nevada, the black trace being this year, and that light green trace being the average. So it is a little bit below average, but you see the bump up in November from the rain and snow, and the fact that the temperatures stay cool allowed that soil moisture to keep climbing a little bit and not continue to dry out. Last year we had that massive October storm, and so we had really high soil moisture. But by the time we got to the start of this water year and into November, that was all but gone. And so we're starting over with soil moisture, and we need some more rain and snow to keep that going. And so getting back to the long-term drought situation, the reservoirs all across the region, both states, are very low, with a few exceptions of some reservoirs, which is mostly due to how those are managed. But most of the major reservoirs are well below average. We can have a whole other webinar on Lake Mead and the Upper Colorado River Basin, but that's at 28% of capacity right now. Most of the major California reservoirs are below average. Lake Tahoe has fallen below the natural rim again, which is a very good indicator that we're in a pretty substantial drought in the region. It's not unprecedented for that to happen, but it is a very good indicator of a severe drought in the region. So we're going to need a lot of water in the system to replenish these reservoirs to really bust the drought. And yeah, just to emphasize that, we have a long way to go, and we really need those core months, December through February, to deliver storms to really have a shot at recovering from this drought. So to now move forward into the future a bit and talk about what's coming ahead. I did want to mention the weather outlook over the next week, because it does have some good potential for more rain and snow and cold to the region. The graphic on the left is from the California-Nevada River Forecast Center, and the data is from the Climate Prediction Center, showing the odds of above or below normal precipitation over the next 6 to 10 days. And so the entire region has tilted odds towards above average precipitation, with about a 50 to 60% chance of above average in those darker green colors. And so the graphic on the right is just an ensemble forecast graphic showing a deep area of low pressure coming down the coast. And this is for early Thursday morning. And so there's a storm system expected to come in Thursday into Friday, and then possibly again into the weekend, but more uncertainty there. This storm, the storm system over the next week is expected to deliver some substantial precipitation. And so these two maps are from the University of Utah forecast pages, and they show the probabilities of reaching certain amounts of precipitation. And so these show on the left the probability of greater than 1 inch of precipitation, and on the right greater than 2 inches of precipitation. And that's based on a 52-member ensemble forecast. And so on the left, any of those darkest colors of red indicate that about 90 to 100% of those 52 forecasts show greater than 1 inch of precipitation over the next week. And so when you move to the right, to the greater than 2 inches, the odds go down a bit, but still it's pretty high at about 70 to 90% chance of 2 or more inches of liquid precipitation across the Sierra and parts of the coast. And that would equate to 1 to 2 feet or more of snow in the Sierra. But again, there's no guarantee. This is still 4 or 5 days away, and we've seen these change before, but confidence is increasing that we will have a good event coming through Thursday, Friday. So finally, to move on to the seasonal outlook, I wanted to first talk about ENSO, the El Nino Southern Oscillation, and how that relates to the seasonal outlook. So these bullets below are directly from the Climate Prediction Center. So we are still in a La Niña. There's a La Niña advisory. This is now the 3rd year of La Niña in a row. This is the cold phase of La Niña, of ENSO, excuse me. And this is expected to persist definitely into the winter, but then begin to weaken and transition into ENSO neutral as we move into the late winter and into spring. ENSO is a pattern related to the ocean and the atmospheric connections in the tropical Eastern Pacific Ocean. in about the area, that box that I've drawn here on the map. And again, La Niña is the cooler phase of ENSO, where the ocean temperatures, the sea surface temperatures are cooler than average. And so you can see that pattern where all the blues along the equator there. So we've been in this La Niña pattern going on 3 years now. But what does that really mean for seasonal precipitation? Well, for parts of the region, it really is one of the biggest sources of seasonal predictability. So predicting 1, 2, 3 months in advance what the climate conditions could be like. And this is particularly so for the southern parts of the region, Southern California and Southern Nevada. And so we have a graphic here that's showing the total October through March precipitation on the vertical, and then the La Niña state the ENSO state on the horizontal. And so I've highlighted all the years there that have been La Niñas. And so this is for the southern coast of California climate division. And what we see is that the majority of the blue dots there are below average or lower precipitation totals compared to the ENSO neutral and the El Niños. There is an outlier there from one year, I think that was 2011, but most of the La Niñas tend drier, but there is still some variability. And of course, there are some outliers. And so every La Niña is different, but there is a fairly consistent pattern here in Southern California. But that changes quickly as you move further north into the mid latitudes of the Western US. So this is the same graphic now, but for Northwest Nevada, bumping against the Eastern Sierra Nevada there. And so the correlation basically goes away. There's a much bigger range of outcomes for the La Niña years. Some are wet, some are dry. It may lean very slightly drier, but it's much less. La Niña is much less of a predictor of the total October through March precipitation in this region. And so another point here is that La Niña is just one factor that influences our winter weather. There's a lot more going on sub-seasonal wise, things that can control how atmospheric rivers, for example, come into the West Coast, and a handful of those atmospheric river storms can really make or break a year. And those can still occur during these La Niña years, even in Southern California. So the forecast, as I mentioned, this is the ENSO forecast now. On the left, it's showing the probabilities of La Niña, neutral, or El Niño. And we see that going into the winter, there's very high odds of the La Niña continuing until we get into late winter and into spring. And that's when ENSO neutral is favored to take over the La Niña pattern as the sea surface temperatures are predicted to warm a bit. And also the La Niña has likely reached its seasonal peak right now. And so this could all play into how the weather patterns change as we transition into spring. And so lastly, the seasonal forecast for the core winter months, December through February. Again, this is from the Climate Prediction Center, and the graphics are from the California Nevada River Forecast Center. And this is really showing how heavily these seasonal outlooks rely on the La Niña pattern, because what this is showing is a higher odds of above normal temperatures and below normal precipitation in the southern portions of the region, with equal chances of above or below temperatures and precipitation for the northern parts of our region. So a lot less confidence there. And even in the southern parts, you see 33 to 40% chance of below normal precipitation. That increases a bit more to 40, 50% as you head further south. So some key points to wrap things up here. Yes, the entire region is still in a drought that began in 2020. The storms in November were good, and that was good to get the snowpack going, but we need that to continue through the winter and into the spring. I really want to emphasize that cold November we've been having, and it's expected to continue to stay cold for a little bit. May seem trivial, but it really helped to reduce the evaporative demand, soils drying, any snow melt in the mountains, and also that fire danger. So to get out of this drought, we really need a well above average water year, good snowpack, and or several years in a row of wet conditions to kind of really reset the conditions in the region. And the outlook is favoring drier conditions, especially for the southern portion of the region, mostly due to that La Nina pattern, the third year of La Nina. And again, every La Nina is different, and there's a lot of other factors that can influence winter storms in the region. And so I will end with that. And I'm not sure if we'll take questions now or at the end. But
Thank you so much, Dan. Great overview of current conditions and outlook. I think first time, if people have questions, they can put them into the questions in the webinar panel. But we'll turn it over to Nate Patrick from the California Nevada River Forecast Center so he can highlight some of the forecast products on the CNRFC page.
All right, thank you. Can you guys hear me?
Yep, sounds good. And we can see your screen, though we don't see the very bottom of it. So maybe
that's fine. Yeah, it's just because of the website, the way it's set up. So my name's Nathan Patrick. I'm a hydrologist with the California Nevada River Forecast Center. Today, I just wanted to take some time to demonstrate some of the content that we have available on our website. We have many users that are interested in different timescales and different products. So hopefully I'll be able to just highlight some of that content for the purposes that you might be using it for. I guess two things about our website. It's highly interactive. There's a lot of customizability that you can do. And in addition to that, a lot of the data that is available on our website is pretty dynamic, and it changes. So you can see over here on the time, it's updated as of just a few minutes ago. So it's not necessarily static, although you can generally definitely generate static images for your use. There's a lot of ability to both download data and import it into GIS tools, as well as produce static images for your purposes. So I'll just hopefully take some time today and demonstrate some of those things. Really quickly, up over here, up on the links, we do have a mobile website version of this, which can be helpful if you just want to get access to some of the data from your phones or your mobile device. It won't have all the same displays and everything else, but the content is available through this link. And as you dig further and further into the website and go down different menus, you can always return back to this home page just by clicking the home button here in the upper left. So just to start off, this is our overview map that we have in just kind of showing some of that interactivity. You can change the map background to what you might want. You can play with different overlays, and then you can actually download a PNG here. If you were to actually scroll down a little bit, we have the capability here to download a lot of the stuff into either KML, XML, and CSVs as well for various things throughout the website. And so you can do the same sort of things for like drainage basin shape files. So really highly interactive based on what people might want to use it for. So on our main sort of overview, this is kind of just our static view when you first come to the website. The green points are official forecast points that the River Forecast Center forecasts for. And usually what that means is there's both a rating, but there's also then impact. So if I were to click on Pohona here, for instance, it would bring up this location. It would provide our single deterministic or single value forecast going into the future. And if I scroll down a little bit, it will actually have then impacts at different stages of what could occur if the forecast were to reach that. We also have probabilistic forecasts, and I'll show that a little bit later. But for instance, if you wanted to scale this plot to flood thresholds, this would actually show, the flood threshold is defined as 10 feet, and then you can actually click over here, and you can download this then in a PNG, a JPEG, a PDF, or you can download it in a CSV, and it will actually provide these data values in there. But going back to our home page again, some of the other products that I just really wanted to highlight was kind of our short term, and then this is kind of our menu where you can go down and select a variety of different things. But to just highlight, for instance, one of our QPF, this is what our in-house meteorologists produce. And I probably forgot to mention this, but during the winter time, so from November 1st to April 1st, we are producing routine forecasts twice a day, both at 9 a.m. as well as 3 p.m. And if the weather warrants or if conditions on rivers meet certain thresholds, then we will actually expand our operations to perhaps even have up to 4 forecast points throughout the day. So this is just showing the QPF that our HAZ forecasters have produced today. The latest forecast that was put out this morning, and you can do, like I said, a county overline if you want to see counties on this, and you can cycle through and see what the different precipitants, for in this case, the 24-hour QPF going forward, and we can sort of see that storm coming in later in the week in what our meteorologists have forecasted. We all start, our meteorologists are starting with the same QPF that nationally would be produced and that WFOs or weather forecast offices produce. But we retain the ability to slightly modify the precipitation that we use for our models for our hydrologic needs. So our QPF may not exactly match what might be produced by a weather forecast office or by the Weather Prediction Center, for instance. We do have the ability to, for our own needs internally, to deviate slightly from those values. So it may not exactly match. And the same sort of thing, you can download this QPF down here. There's a way to get a gridded version of it. And then, so that's also useful if you wanted to pull in our actual QPF for your purposes. Likewise, we also do, we have QPE where we actually quality control QPE. So we have point data and then we have, so you could just sort of see there's probably nothing today or very little amounts here in the Northwest. So this is kind of the raw values for 24 hours, and then we'll QC that and allow point values as well. But we also then have to produce a gridded product that we use for our models. And so we typically ingest into our models 6 hours of QPE, which can then be disaggregated down to hourly if the model is actually run at an hourly resolution. So we do have, I'm not sure why, there's a little bit of a 24-hour gridded QPE coming in. And same sort of thing is you can download this data as well in either a CSV or even in a gridded format, like for GIS purposes. We kind of distribute the precipitation into our basin averages, and that's what our models are using. So you can also get the basin averages that we would use for various basins. And so that's kind of our QPE data that you can then look through. Other things that we have is we have snow data. So you can sort of, if there's the no risk national product, which you can overlay and view that. There's point data, but then we also have down here is we have the ability to display what we're actually modeling both in our various zones that we do in our model. And so this will actually show that. So those are sort of the some of the meteorological forcings that maybe go into our model. And then kind of quickly going back to what our river forecasts are, we, in addition to flood purposes, we're also interested in the water resources aspect of things as well. So we do have a lot of probabilistic forecasts as well. And so if I'll dig into that really quickly here in a few minutes, but if you want to just see what is the peak exceedance at one of these forecast points, or even you can kind of get a look at that at the 10% probability exceedance for over the 10 days. If I were to actually zoom in and click on one of these forecast points, we have the ability then to go to an ensemble forecast. And so this is kind of a probabilistic approach, which can be useful for water resources and everything else. And once again, we have the ability here to change it to 10 days, and all of our content is interactive. So I can actually draw a box in here, and this will tell us the probability of exceedance. It'll redraw this table just over this time period and recompute what the chances of exceedances over that time span. From a water perspective, water resource perspective, we have these seasonal trend plots that are available through our ensemble plots. And it'll basically, what this is showing, what is the probability of reaching certain volumes, at least for this one, it's the seasonal, so from the April to the July time period based on where we are right now. And so you will have the daily observations here shown in gray, and then we'll have the various exceedance probability levels highlighted in here. And so maybe it might be a little bit easier if I switch back. You can pick previous years. So if we look at 2022, you can sort of see as we move further in through winter, these thresholds or these probability exceedance intervals, they kind of converge, and you know, we have increased confidence of where things are headed for the seasonal water flow. And so all this is interactive. Like I said, you can download it in tabular view, you can download it in CSV, XLS, any formats that you may want. You can toggle on and off what you might want to look at. We have 4 by 5 day probability accumulation. So this will show accumulation at this point for the next 5 days, 5 days after that, 5 days. So it helps water managers thinking about how much volume is going to come into a particular reservoir. We have the water year trend plots, which shows the entire water year where levels will end up being, the mean, the median, where we're at. And then we also have a multi-water year. So if I were to click on this one, there's it'll show 4 years. So you can see where the 4-year record would be 817,000 acre feet, and where things are headed at the various trace levels, the 90th percentile, 75th percentile, the median, and up to the 10th percentile. And then lastly, we do have a build your own. So if you're adventurous, you can select a lot of things that you may be actually interested in. You can actually generate your own sort of HEFS or your probabilistic analysis. With that, I think that's all I'm going to say. If you have specific questions on how to use, one more thing I wanted to mention really quickly. Our probabilistic forecast, we get questions a lot about, well, how does it work and how is it, you know, what does it mean? If you go over to this hydrology tab and you come down here into the hydrologic ensemble forecast service, there's some really good informational videos. They're only about 4 or 5 minutes. There's 3 or 4 or 5 of them. They'll help explain a little bit of what's, you know, being generated in those products and give you some information on how to decipher those. And then if you want a more in-depth look, we just created this. Brad Moore, a hydrologist at our center, produced this document this summer, which gives you all of the technical sort of information of how the ensemble forecasting system works at the CNRFC. And so that can be really useful if you have additional questions. Lastly, if you have any questions on our website, or you're looking for something and you don't know how to find it, if you scroll all the way down at the bottom here, it has our email address, and then we will respond to you and hopefully help you find what you need on our website. And with that, I will turn it back over.
Okay. Thank you so much, Nate. And being an avid user of the CNRFC website, I just want to express my appreciation for how useful and how many different ways you can slice and dice it and use it. So I think you guys do an amazing job. So thank you for that. It's a really, really, really informative website. So I'm going to wrap up by talking a little bit about 2 different websites for various different forecast products. I know I have the website for the Southern or Western Weather and Water Extremes set, but I'm actually going to start with the California, Nevada one with 2 main websites in terms of water storage tracking. And this is, if you look at the drought status updates, we use these a lot in the drought status updates, but it's been developed by Mike Dedinger. And it's the combination of the water stored in the reservoir plus the snowpack. And I'm just going to highlight this one from last year, actually, because a lot of the snowpack information from DWR that is used to create this doesn't come online until a little bit later. So what you're seeing here is this is for 28 Western Sierra reservoirs, and the blue line is the 2000 to 2015 normal of what's stored in those 28 reservoirs, and then the snowpack is the gray. And then the blue is the reservoir storage, and the yellow is the reservoir plus snowpack. And because in California and Nevada, the combination of the snow and reservoir storage is so important, this is one way that you can see both the snow and the reservoir. And so these have, he does these for multiple different reservoir systems. I'm just kind of scrolling through very quickly here. The ones where the snowpack has been updated, Mike has updated them for the 2023 water year. And so you can see these and pick your reservoir of favorite reservoir system and see how they're doing so far this year. And then here, as Dan mentioned, the Lake Tahoe, it's how it's below the rim here. And he also does this for the Colorado. The other one that I wanted to mention is precipitation tracking. You actually saw Dan pull one of these figures for his presentation as well. And so this is looking at changes 3-day, where we are in the water year, what percent of the water year normal are we at? This is for San Diego County. And the 1-day change, the 2-day change, and the 3-day change. And then you can kind of see where we are in terms of the water year so far. And with this, you can kind of pick your region of preference. There's Los Angeles, all of California, the 8-station index, Clark County, in Nevada, and the Reno-Carson City area. So after a storm, if you're curious of what percentage of water year normal is this, you can see, and it shows the record low, the mean, and the record high. So like I mentioned, the other website I was going to highlight is for the Center for Western Weather and Water Extremes. We work largely with atmospheric rivers, and a lot of the forecast products are focused on atmospheric rivers. And so I'll just highlight a couple of the different forecast products. To get to those, you go to forecast and AR for atmospheric rivers, integrated water vapor, IWV and IVT. So if I click on this, and then so what you can see is here are certain maps. These are, and you can see various different models, and so you can see how much they agree. And the shading is the shading of integrated water vapor transport, and so it's both the wind and the water vapor, which are two components that are really important for producing precipitation in our region. And then here are the different models. The GFS is the US model, ECMWF is the European model, and NAM is another US model that does not go out as far. I will say right now, currently we're having trouble getting the ECMWF data, and so those have not been updated on the website. We're actively working on it to improve that. But then you can use the arrow button and just scroll through and see the forecast. And so as Dan mentioned, later this week, we may get some precipitation, so you can see the system here coming in. And then as it brings in other moisture and winds, moves down along the coast. And so this is from the US model. There are a lot of other products on the forecast products on the website. Another one that I'll highlight, this is called the Atmospheric River or AR Landfall Tool, and this is using an ensemble, and it's showing the probability of all those ensemble numbers of an atmosphere of IVT, that water vapor and wind, reaching a threshold of over 250 kilograms per meter second. And so the higher the probability, the more likely there is that there'll be a feature where there's potential for precipitation coming in. So this is a great situational awareness tool. You can change between ensemble, the US and the European. I will say that, like I mentioned, we're having trouble with the European data, so this hasn't updated, but hopefully that will be fixed in a day or two. For those people that are really interested, you can also look at this because the direction of the storm is really important of how it interacts with our topography. You can also see the direction of the winds, and if you choose this one with vectors. I'll go back. And then you can also change the location of whether it's at the coast, the foothills, or inland on the eastern Sierras. The other thing that we show is this is called a plume diagram. And so it's, again, this integrated water vapor transport, the winds, that you can pick your model, how far it goes out, your transect, so whether it's coastal or foothills, and so it moves in. And then you can also pick your location. So this is at 38 North. And what this is showing is using those ensembles, so multiple weather forecast renditions. And so you can see the green is the mean. All these individual gray lines are each ensemble member. The blue is 1 standard deviation, and the red, or the blue and red is 1 standard deviation plus or minus. And so what this is showing is the ensemble uncertainty in an event, and I should say the black line is the control run. So that's the deterministic, that's the kind of the best guess. And so you can see for later in the week, and as Dan mentioned, even maybe later, how wide and spread out this is. This means that there's a lot of uncertainty in what the forecast is. Whereas, a little bit closer in the week, the red and the blue and everything's closer together. So there's less uncertainty and there's more certainty in that forecast. And this is showing where your location, and you can pick your location. The other thing I will highlight is the atmospheric river scale. So as Dan mentioned in his presentation, we still need quite a few storms, and oftentimes in California, Nevada, those big storms for us during these winter months are atmospheric rivers. And so what the atmospheric river scale does is it's a ranking of the strength of an atmospheric river and the indication of whether it will be beneficial or hazardous. And so generally, the ones that are shorter and not quite as strong are more beneficial, whereas the ones that are longer duration and stronger are more hazardous. And so the 1s and 2s are generally beneficial, whereas the 5s can potentially be hazardous. So antecedent conditions matter quite a bit. There's a quick video on the website if you want to learn more about it. And then what we have here are the past 7 days of what it's been. And I should say the AR scale, unlike say the hurricane scale, where a hurricane has 1 scale for the whole storm system, the whole hurricane, an atmospheric river scale is point dependent, because depending on the location, the duration or the intensity can change. And so it's based on the maximum intensity and the duration at any one location. And so all these dots along the coast, you can see whether in the past week, whether there's been an AR and what ranking of that AR. And then similarly, here's the forecast for the AR scale for the next 7 days. And you can choose your model between the US and European, and you can also choose your location of these dots, whether it's coastal, inland, or foothills or inland. Similar to the plume diagrams before, we also have plume diagrams for the AR scale. And so I'll just go down to where we saw it before. So at 38, you can pick your location. So this is what was observed, and there's been no ARs and here's where we are at 38 North. But here's what's coming up. And so like I showed before, you see this event coming up here, but the duration isn't long enough that it actually triggers an AR scale ranking of anything. So it's highlighted in that it's in this box that it's above this 250 threshold, which we often use to indicate an atmospheric river or not, but the duration is not long enough, and so it does not have a ranking. But then this is another situational awareness tool in understanding what may be coming and what precipitation may be coming from this. And the last thing I will talk about are these ensemble forecast products. If I again go down to 38, where we were just looking. So this is showing each of the various different ensemble members, and most of them we're showing that it's not an AR, doesn't have an AR ranking because the duration is so short. But you can see each of the different ensemble members, when it's starting, when it's ending, and what the potential ranking is. And then this one in the kind of later in the week and over the weekend that Dan mentioned that there's a lot more uncertainty, and you can see it here with that. The other thing I will go up and highlight is what we call our interactive maps. And there's two I'd like to highlight here. And again, we have the GFS, which is the US national model, and the ECMWF, which is the European model. And so you can toggle between the two or even do a comparison between the two. And oftentimes that comparison between the two different models, not just ensemble numbers, gives you a sense of uncertainty or certainty in the forecast, which is super helpful. So what this interactive tool is doing is it's showing the forecasted precipitation from these various different models. And so I'm going to click here, for example, on the upper Yuba watershed. And then if you scroll down, wait, oh, sorry, let me go to the G. I'm going to do the same thing. I just chose on GEFS, this is ensemble, and you can see that it's 30 members. I'm going to choose the same watershed. And so what you can see here in this map is each of the 6-hour accumulations predicted by the control. And then all these little gray lines are each different ensemble members. So you can see the range and uncertainty over the next 10 days in precipitation totals. And the red line is here is the control. So that's kind of the best guess. And then the black line is the mean of all those ensemble members. So you can see what over the next 10 days, how many inches are predicted for that watershed. The second to last thing that I will highlight is our freezing level. Let's see if it will load. Uh-oh. Well, this maybe, there it goes. Okay, so what it's showing is, this is looking at the freezing level, so whether or not the precipitation is going to most likely fall as rain or snow. So for example, let's see, we can choose one of the watersheds up here in Northern California. So maybe we can, yeah, so here in the Upper Carson, what you're seeing in this is the same idea as ensembles before, but this is the freezing level. And the black line is the control, so the best guess. The green line is the mean, and the standard deviation is the one standard deviation plus or minus is the red and the blue. And so this is how the freezing level is forecasted, and you can see at certain points where there's quite a bit of difference between the two, that there's more uncertainty in the freezing level. And then these bars are the 6-hour precipitation estimates or forecast. And what you can, the blue is showing that it's most likely to fall as snow. The green is most likely to fall as rain. And the cyan color is there's uncertainty within that window. And you can see then as, over the next 7 days, there's a forecast of 2.13 inches for the Upper Carson watershed. 10% is forecasted to fall as rain based on the freezing level. Over about 20% is uncertain because it's in that range of the forecast variability, and then 70% as snow. And the last thing I will highlight real quickly is there's some new sub-seasonal to seasonal forecast products on the website. So sub-seasonal is really in this kind of 2 to 4 week time range. And so what this figure is showing is the probability of occurrence of AR if it's below climatology or above. And so oftentimes really looking at this week 3 is very informative. And so for this week 3, which is, it shows the dates here, December 9th to 15th, you can see right now it's showing below normal in terms of number of AR days. So just the frequency they're projecting to be, or forecasting to be a little bit less. Another thing that's really helpful is then you can flip between 2 different models. And again, in this case, if you're seeing similar signals between 2 models, that's an indication of more or less certainty. Whereas this model is showing higher, this is the Canadian model, higher atmospheric river occurrence frequency. And so the fact that the 2 models, there's disagreement there means that it's more uncertain. And the other part that's shown here is a ridging forecast. And so this uses the US, a US climate model that's run out for quite a few weeks. And so it's an indication of looking at all the various different ensemble members and what type of ridge type it is. And depending on the ridging, there's more typical patterns of precipitation. And in this case, in the week 1 to 2, none of these ridging patterns stands out. So that means it's highly uncertain. You can also go out to weeks 3 and 4. And again, none of these are all shaded out, meaning there's quite a bit of uncertainty. It's all less than 50%. And you can also go out to weeks 5 and 6. And again, there's not a strong signal is what this is showing because they're all grayed out. And then the last thing I will talk about is going to the home screen, that we do an S2S outlook every 2 weeks. And so that would be here on the home screen. And then also if there are atmospheric rivers that are coming in, do an atmospheric river outlook and describe the forecast. And then you can sign up to get emails for these outlooks when they are posted if of interest. So with that, I will go ahead and wrap up. I don't think I haven't seen any questions, but thank you very much for joining us today. We appreciate you taking the time. There will be a YouTube recording that will be posted on the NIDIS YouTube channel in the upcoming days. And I guess with that, we will wrap up. So have a good afternoon, and thanks again for joining.
In the question box, I don't know if.
Oh, I didn't see it. I'm sorry.
It's okay.
I don't. Maybe Adam, can you read it because I don't see it?
Yep. The first question is for Dan, and it says, what kind of atmospheric dynamics govern or influence the development and track of atmospheric river events that can make or break a water year? And do scientists have a way to predict these factors in advance at timescales better than the weekly weather forecast?
Oh boy, that is a good one. You guys hearing me?
Yes.
Okay.
Yeah.
So that of course is really the question that everyone wants to know is, can we predict those atmospheric rivers and at what lead times? There is a lot of various dynamical patterns that can lead to atmospheric rivers making landfall on the West Coast. A lot of it comes down to where the ridge actually sets up in the Pacific, in the North Pacific, and if that can allow enough moisture to come underneath the ridge to bring moisture into the West Coast via an atmospheric river. One subseasonal process that can drive that is the Madden-Julian oscillation, which is a pattern that changes convection or thunderstorm activity, moves across the Pacific in various phases and intensities, and that can dictate, that could interfere with the La Niña pattern, and for example, for a shorter period of time, allow strong atmospheric rivers to come into places like Southern California. And so, beyond the weather time scale, 1 to 2 weeks, the predictability does go down quite a bit. But Julie was actually showing some really good examples and tools that allow us to at least glimpse into the weeks, 3 to 4, where there is progress being made on being able to have some prediction of at least a pattern change showing the possibility for some of these events emerging. So there are some tools out there, but beyond that week 3 to 4, you're not really going to see the atmospheric river signals in things like the seasonal outlooks.
Okay, and then I think we can probably take 1 or 2 more questions before we wrap up. The next question is, I'm interested in knowing whether the fog belt along the Pacific coast of California makes a difference in terms of a slim band that has better moisture delivery than that area is noted as having.
That for me.
Yeah, I'm not.
Well, I'm not quite sure I fully understand the question. Can you repeat it, maybe?
Yeah, if we don't, we can go. It says, I'm interested in knowing whether the fog belt along the Pacific coast of California makes a difference in terms of a slim band that has better moisture delivery than an area is noted as having.
Like maybe the drizzle effect? Could that be?
Yeah, I don't know if that's referring to like the place where fog occurs more, changing how much moisture in a storm makes it on shore. But yeah, I'm not sure I can really say much about answering that.
Okay, well, let's do one more and then we will wrap up. And then again, if anyone has other questions, we will look at the questions in the box and try to answer them. It says that Dan showed the water year 2017 showed an abnormally high precipitation for California, Nevada. From a water supplies perspective, we would love to get another year like that. Do you know if that year corresponded with higher frequency, high magnitude atmospheric rivers hitting the region? What was the mechanism of transport of that moisture?
Yes. So, I mean, the short answer is yes. We did have a high number of atmospheric rivers making landfall that 2017 water year. And those were responsible for the really big increases in a few day time spans for those big precipitation numbers. And I can't recall if that was a weak La Nina or an ENSO neutral year, but the ENSO signal was not very strong that year. And I know those years, especially ENSO neutral years, can tend to bring some of those bigger atmospheric rivers to the region. And so I think that's partially why folks are paying attention to our transition from La Nina to an ENSO neutral into late winter into spring as a time period for potentially more atmospheric river activity. Of course, that's way too far in advance to make any specific prediction, but so that pattern would allow more moisture to come underneath the ridge from the tropics up into the West Coast, as opposed to these colder, drier systems dropping down from the north, which we can see more of with these more recent La Nina years. And Julie, I don't know if you want to add anything else to that.
No, I think you covered it well. Yeah, the 2017, it wasn't just, a couple big storms. We did have that, but it was quite a few, which really helped. So, yeah.
All right, and with that, I think we'll wrap up. And as Julie noted, the presentation will be posted, and we'll get a summary also posted to drought.gov and an email sent out to everyone who attended and registered with that information. And again, if you asked a question and didn't get answered, we will try to answer it, and you can also email one of us, and we can get back to you also. So thank you, everyone.
Thank you.